Alright, in this video I'm going to be going through some stoichiometry questions involving the limiting reactant of a chemical equation. So let's say you have the question, how many grams of Fe2O3, which is iron oxide, can be made from 10 grams of iron and 7 grams of oxygen gas? And you are given the chemical equation for iron, it's 4 iron, and you have 3 oxygen gas molecules create 2 iron oxides. So before you start anything, you would have to make sure that the chemical equation is balanced. Sometimes, for some reason, sometimes you would have a chemical equation that's not balanced, and you would have to balance it in order to continue and receive a valid answer. So let's check. So we have 4 irons on the left hand side, and we have 4 irons on the right hand, and we have 6 oxygen molecules, and we have 6 on the right hand. So this is balanced, so we do not need to do any balancing in this video. So now let's move on to the second step. So identify what we have. This says can be made from 10 grams of iron and 7 grams of oxygen. So we have 10 grams of iron, and we have 7 grams of oxygen gas. So the reason why I put an equal sign here is the first thing you would want to do is change the grams into moles, and in order to do that is you would have to divide it by the molar mass. So let's start off with here, 10 grams of iron. The molar mass of iron, for 1 mole, it's 55.85 grams per mole. So you would have to divide 10 by 55.85, and that will give you 0.179 moles. And for oxygen on the other side right here, 7 grams of oxygen, 1 gram of oxygen is 32 grams, as one oxygen atom is 16, and oxygen gas is two oxygen molecules, as they're reacting with each other to create a diatomic molecule. So you have 32, because 16 plus 16 is 32, and 1 mole is 32. So you would have to divide 7, which is what you have, by 32, and that will give you 0.219. So you have 0.179 moles of iron, and you have 0.219 moles of oxygen. So just because oxygen has just because iron has the lower amount of moles doesn't necessarily mean that it is the limiting reactant. Alright, so now let's move on to the second step. The second step would be to find the ratio of the reactants and cross multiply by the moles of iron. So let's start off, let's scroll down right here, and let me do that right here. So we have 4 Fe, which is 4 iron, with 3 oxygen gas. So the ratio is 4 to 3. So let me put that right here. It's going to be 4 over 3. So now let me do what the step says. 4 over 3, multiply that by 0.179, which is the moles for the iron that we have, and put that over x, and solve for x right here. So in order, you would have to do some basic algebra right here. Let me switch colors. You'd have to cross multiply, so you would have 4x is equal to 3 times 0.179, which would be 0.537, and you would have to divide both sides by 4 in order to get x by itself. So when you divide both sides by 4, these two cancel out, and you're going to get x is equal to 0.537 divided by 4, which would give you 0.134. So now, what does this tell you? This tells you you are not going to be using this number anymore, 0.134, but this tells you that iron was the limiting reactant. So in this scenario, the lower number would be the limiting reactant, but just to note, it doesn't always mean that the lower number of moles that you have is the limiting reactant. So now we know that iron is a limiting reactant. Alright, so now going back to the question, it's not just asking what's the limiting reactant, it's asking how many grams of iron oxide would you create. So now let's do the rest. So now the third step that you would need to do, let me clear up some space. The third step that you would need to do is find the ratio of the limited reactant to the product that you want to find, which is the iron, which is the limiting reactant, to the product, which is iron oxide. So let me get this done right here. So you would have 4 Fe, and going back to the chemical reaction, you would have 2 iron oxides. So you have 2 iron oxides. So So you have 4 and 2. The ratio is 4/2. And then you would have to multiply that by the moles of oxygen that you have. So you would have to multiply this. Let me get rid of this. So you have 4/2. Let me put this right here, and you have to put that as an equivalent ratio to 0.219, which is the moles of oxygen, and put that over x, and you would have to solve for x, which is what we did previously. So you'd have to cross multiply. So we get 4x is equal to 0.219 times 2, which is 0.438, and from here you would have to divide both sides by 4. The 4's on this side cancel out, and now you would simply get, running out of space right here, x is equal to 0.438 divided by 4, which will give you 0.109. Alright. So this is the amount of moles that you have of your answer, the amount of moles. But going back to the question, it's asking how many grams, it's not asking how many moles. So this is the very last step, and you would have to convert the moles, which is 0.109. So you would have to convert the moles into grams, right? So let me do that right here. Let me clear up some space first, because we are definitely running out of that. So when converting the moles into grams, it's simply the opposite of what we did right here, which is when we converted the grams to moles, we're actually going to be multiplying instead of dividing. So we have 0.109 times the molar mass of iron oxide, which is 159.7. Alright, and you would put this over 1 as it is a ratio, put this over 1, but these two cancel out, because anytime you had both denominators as 1, they could simply cancel out, and you could multiply the numerators, and that would give you 17.407, and this is now grams. So this is the answer that you would receive. So to conclude, you know that from 10 grams of iron and 7 grams of oxygen gas, you would get 17.407 grams of iron oxide. Alright, this was some basic information of stoichiometry and limiting reactant. I can make another video on how to convert moles to mass and mass to moles, and explain why you would want a number in moles instead of mass, and sometimes in mass instead of moles. Alright, thank you for watching.